Next up, we have Nelson Rios, who'll be talking to us about georeferencing fun stuff.
All right, thank you. My name is Nelson Rios. I'll be talking a little bit about how we're handling georeferencing within the DigIn and ESB TCNs. And my co-author, Dr. Nicola Bailey, who's not here today, but he's with Aquatics, an organization that is also heavily engaged in the georeferencing aspects, and I'll talk about his work in shortly. So just to get started, as kind of previously mentioned, we're using GEOLocate and GEOLocate related infrastructure for a lot of the core of the georeferencing. So for a little background, GEOLocate is an application that was released probably about 2003 was the initial release. It came out as a desktop application. And then over the years, there have been a number of key developments, some of which are very important to enabling the kinds of georeferencing that we're doing now with ESB and TCN. One of the biggest was, expanding from, it was originally developed as something that was focused in just North America. And in 2006, we expanded to global scope for georeferencing capabilities. In 2008, we built the CoGe platform, which is this thing called Collaborative Georeferencing that is heavily used by the TCNs that are doing large-scale georeferencing. Another major development that was important for this kind of work is in 2009 and 2010, we made this big transition from a desktop application to the web and pretty much deprecated all the desktop stuff and moved to a web-first environment. And then between 2012 and 2015, one of the biggest developments was that the CoGe, the Collaborative Georeferencing platform, was actually used for an aquatic digitization project for FishNet, where all the records within the FishNet network were georeferenced by a small number of institutions. So I think in total, we did about 70 institutions worth of data with only about 13 technicians involved in georeferencing. And that data helps actually improve the georeferencing process for future aquatic organisms. And there was some marine georeferencing involved in that project. In 2016, there were some communication protocols between the CoGe platform and Symbiota that was developed, and that will allow us to communicate with invertebrates back and forth. And so we're leveraging those advancements as well. And then the biggest is now in 2021 are the developments that we've added that are very specific to ESB and DigIn and accomplishing the goals of those projects. And so just to give you a typical process of what is involved in georeferencing, we take locality descriptions, which are, human readable text descriptions of where something was collected. And then we run it through some kind of georeferencing algorithm. And so what that outputs is some coordinates. Sometimes it'll also output some uncertainty depending on which algorithms we're using. But then that's just giving you a best guess of a number of candidate locations that you might be interested in evaluating. And that's the easy part of georeferencing, is that, you're just feeding data into something and getting some data out. All the work comes in that final step, the manual verification. And that's where humans actually look at the results of the automated process and then make decisions as to whether the uncertainty is appropriate or the points are in the right areas. Do they need to adjust to create polygons to better describe locations and stuff like that? So that's the core of how georeferencing works. And then around that, we've wrapped something that we call CoGe for collaborative georeferencing. And so this is a platform that's built for managing the data, the infrastructure, the people involved in large-scale georeferencing projects so that you can upload large data sets, hundreds of thousands of records, and we can handle all the complexities of taking 100,000 specimen records and just isolating the unique locality information amongst all of those records so that you're not georeferencing, the same location over and over and over again. As we see that a lot with institutions that aren't using the collaborative systems. We'll see, species A collected, 5 miles off of some place, and then you'll see the exact same record georeferenced over and over again with different species names. And that's a big waste of effort there. And so we try to reduce those redundancies through this platform here.
And then we also try to identify not just records that are the same, but also similarities. So if two records are kind of syntactically similar, they georeference to the same location, for the most part, we try to identify them as saying, hey, these two are similar. Let's see if you can evaluate them and georeference them together in one big one big bulk set of data. And then there's also tools for doing bulk review at the very end of the process. So we could say, hey, let me look at all the records for species A and see, are there any outliers? Or let me look at all the work that this technician did. And I can, if I only wanted her to work in, Rhode Island or something, are those records all within Rhode Island? And so along those kinds of lines, we can identify outliers. So the main enhancements that were done as part of these TCNs involved the support for complex geospatial annotations, adding a number of marine-specific layers to the applications, support for integration of data from custom marine gazetteers that were built, and then something that is still in development is being able to utilize data from cruise and station data and build gazetteers around that. And then this isn't directly related to this project, but also being able to link out to supplemental georeferencing services. And so you may have heard Julie Allen's talk in the plenary where she mentioned bells, and that would be that kind of thing where we can, rather than using a GEOLocate-based georeferencing engine, we could use bells, or we can combine them both. Oops, sorry. So I'll talk just briefly about each one of these items. And so the geospatial annotations, normally when we think of georeferencing, we think of a point, and we put a point down and we create an uncertainty around it. And that's kind of the minimum that you want to represent a location. But marine locations tend to be a little more complex than that. We have islands, we have small little reefs, and things that you want to describe. You have transects, you run a start and stop coordinate for a trawl. So we want to be able to describe all these kinds of complexities. So we added another option in there where, even though you're still trying to come up with a consensus point and an uncertainty radius, which makes your data compatible with with most of the data that is published out there, you're also able to tag and annotate a record however you need. If you need to add lines, multiple points, if you need to create donuts, and it's mainly this donut feature around islands or being able to select multiple little donuts around islands. So those are the key features that were added. And then being able to tag any of those annotations, you might be able to say this represents a trawl, or this represents an uncertainty that you're trying to create of a polygon or something like that. So you can tag these various features however you want. Unfortunately, there aren't a lot of standards as to how this will get pushed into aggregators like GBIF and things like that. So that's still work that needs to be done, but at least we're capturing the data that makes this available now. So a number of marine-centric layers. We added layers. So these are overlays that can be added inside the GEOLocate application. So currently we support all the major layers, Google, Microsoft, number of layers from Esri. But we've also there's also open layers is also, not open layers, OpenStreetMaps is also supported. And then we have these layers as overlays that can be added, which include the exclusive economic zones. We've got NOAA navigation layers, and then we've got the 2019 and 2022 JEPCO bathymetry layers so that you can see depth lines. And we'll probably start seeing how we can actually use that data in the georeferencing process as well. Right now, it's just a visual overlay that the technicians can see when they're georeferencing. We also built some specific marine-focused gazetteers so that when the georeferencing happens, the automated process, rather than leveraging, terrestrial gazetteers, which is what the bulk of georeferencing utilizes, we wanted to have as much marine-focused data in there as possible. And so the image on, I guess that would be your left, is showing data from FishNet and MCZ base that we took, and both of these are relatively vetted georeference data sets. The MCZ base was proofed by people at Harvard, and the FishNet data set came from that large georeferencing project. So these were the results of that georeferencing that we had a lot of confidence in, and we used those to build gazetteers that were involved in the georeferencing process. So when you submit a record to the CoGe system or to GEOLocate, it leverages these gazetteers and says, hey, does this record exist, or does it match something in one of these gazetteers? And if so, let me assign coordinates to that. And then we also built a number of other gazetteers based off of some publicly available data sets. using the GNS undersea features and another data set on world seas. And then as I was mentioned earlier, or hinted at, this idea of being able to build cruise ship and expedition data. And this is probably the more complicated aspect, and this is something we haven't fully integrated yet. But it involved going through and producing a list of all the research vessels that we could get our hands on. And that was just doing a search on Wikipedia. We got a big list of names. And then using that list of names to start querying these various different data sets. So we queried everything in FishNet and tried to do some natural language processing to say, hey, which one of these records have references to these cruise ships or these expeditions or station numbers. We grabbed data from the Biological and Chemical Oceanography Data Management Office. Hexacarillions of the world, they had a data set on expeditions that were available online for some time. We grabbed that data set as well. And then finally from the USC libraries, they have a number of station records available. And so we combined all that together, and we're in the process of trying to build a expedition data set that we can leverage in the georeferencing process. So as I mentioned, there's the ability to select the georeferencing engine here. You can see where you can select either GEOLocate or BELS. There could be in the future for development of adding other georeferencing engines, potentially just saying, hey, I want to run this all through, let's say, Google Google geolocating service, if you will, and things like that. So I'm running out of time here, so I'll try to quickly hurry up here. There are two, the two projects are very similar in that they're using the same infrastructure, but the mode of georeferencing is actually quite different. DigIn is focused on, they're doing the collaborative georeferencing. It's global in scope, but the key difference is that it's an outsourced georeferencing process. And what I mean by that is all the georeferencing is going off to one group or one institution, and that would be Aquatics, which is run by Nicholas Bailey, who's the co-author on this. And their group is involved in doing all the georeferencing for the entire TCN. And we can contrast that with the ESB, where all the georeferencing is happening in-house, if you will, where all the institutions or all the partners, all the collaborators are each responsible for some portion of georeferencing. And so there we usually divide up the data geographically and say, oh, we're going to assign Rhode Island or this particular area to, institution X, and this particular area to another institution. Where, the DigIn model, we just send all the data to this group at Aquatics, and they do all the georeferencing for us. So the original workflow was kind of designed like this, where there would be at the bottom, there's some you can see the original source data sets. They can push their data into InvertiBase or Symbiota, or they can just take a CSV spreadsheet, and all of that communicates into the collaborative georeferencing data portal. And then from there, the data can go out to GEOLocate for georeferencing, visualization, and correction by the various technicians at each institution. And then within the CoGe system, there's various elements so that we can get reporting and we can see where things are in the process. Now, that all looks great, and this slide makes it look like there's a lot of transfer back and forth, and it's a very straightforward process. But actually, the hardest part, one of the hardest parts, it's still a challenge for georeferencing and all forms of digitization, are the diversity of systems that are out there and being able to repatriate data back into source institutions. So it's pretty easy for us to say, hey, we're going to push things back into Symbiota because we have pipelines already built to do that. But we don't have ways of getting data back in from the CoGe system to all the various institutions, for going into EMU, going into Arctos, going into MCZ base. There is a small connection between Symbiota and Specify that's currently being developed that would make it a lot easier for stuff to go from CoGe to Symbiota and then from Symbiota back into Specify. But there is still some repatriation hurdles that we need to resolve. Here you can just see a quick review of the status. I don't know how well these slides show up, but you can see the ESB results right now still focused right on the northern East Coast. And then DigIn, you can see the georeferencing that has been going on. ESB has been a little slower to get started. We've had a lot of test data sets that have been run, but now we're really getting to the point where we're starting to move a lot quicker and produce a lot more data. And with that, I'll take any questions that anyone may have. Thank you. Yes?
You were showing the different shapefile configurations. How are a lot of databases handling that shapefile? How's that getting?
So unfortunately, most natural history collection data, in fact, all of them that I know of, are non-spatial databases. So there's no real way to import a shape file or to represent your data as spatially. The databases themselves are not spatially aware. So normally there is just a field for latitude and longitude. Some of them will store history of latitude and longitude, so there can be change over time as the georeferencing changes and we become more knowledgeable about where something was collected. But the ability to integrate polygons and complex shapes and those kinds of things is still a challenge for a lot of these databases. And they're usually stored as just a big blob of text or a big blob of binary data, which becomes very difficult to mine and perform queries against it. And so hopefully, you know, as we produce more complex geospatial data, the natural history databases will hopefully increase their complexity and add spatial engines behind their data models. Any other questions? I think we're out of time.
Thank you so much. So for our next presenters, we have Vanessa Del Navas and Alexandria Gower from Santa Barbara.